Hello and welcome to Tribe Topper. In this video lesson, you are going to learn about work. So what do we mean by work? See, in terms of physics, it's really important that whenever you apply a force, the body should be displaced. Like I would say, if it's not that if you are sitting and studying whole day, you may get tired, but in terms of physics, you're not done any work. You haven't done any work because you did not move from a place. Or if a person is just trying to push the wall whole day, again he applies the force but there is no movement, so no work is done. So how would we define work? We say when force applied on a body displaces it, work is said to be done. Now what are the things on which we would say this work done depends on? Number one, the force that you apply. That means greater the force, greater will be the work done. Secondly, it depends on the distance moved. So we can say distance, which we generally denote as S. Force would be F, distance or displacement would be S. And thirdly, it also depends on the angle at which the force is applied with respect to the displacement. So that's an angle theta between F and S. Like for example, you can imagine this as when you're dragging your luggage on the airport. So you are pulling up your bag in this manner, right? You apply a force in an upward direction like this at an angle theta with the horizontal. So your luggage moves this way horizontally, but you are applying a force at an angle because it is rolling, so you apply it at an angle, right? So therefore the expression for the work would be what? Work done would be given as F times S times cos of theta. So work done is equal to FScosϴ. So if force is 0, obviously no work is done. If you move something and put it back, so like in a circular motion, your work is 0 because you come back to the same position, and then the theta also decides the work done. Now the thing is, SI unit. Yes, the unit is very important. The SI unit of work is joules. We generally denote it as J. Now how do we decide? Interestingly, whenever this theta comes into play, there are always three special cases. So here also we have the first special case, that if your theta is 0, that means like we were doing here, the force applied is in this direction, the displacement made is also in this direction. So F and S, they are both acting in the same direction. So your theta is 0 and cos 0 is 1. Therefore, we would say what is work done? That is F times S times cos 0, which is 1. This is known as the positive work done. So the example would be a ball or an object falling down. Why an object falling down? Because gravity pulls it down and the displacement also is happening in the downward direction. So just the opposite would be if theta is equal to 180 degrees. So cos 180 is -1 and cos of 180 is -1. Therefore, this leads to an expression work done is minus Fs. This is known as negative work done. Can you think of an example for a negative work? I believe we have just learnt about friction in our few lessons before. So friction opposes the motion. So if an object is moving in the forward direction, friction pulls it back. So if something is going forward, the friction pulls it backward. So S happens forward and force of friction pulls it backward. So theta is 180 degrees, right? So that will produce a that will produce a negative work. And the third is the case of 0 work done. When your theta is 90, we know that cos of 90 is 0, and in that case your work done would be 0, right? And that is the case of a person. If you were to say you are carrying a load and moving vertically, let me show you. So suppose a person is carrying a load on his head and moving this way. So the weight that acts is in the downward direction that's the force, and the person moves in this direction, that's the direction of displacement. So angle theta is 90. So the work done would be 0. So that's all for this video session. I hope you've learned what is work and how do we determine work. In the next video session, you are going to learn about energy and its various forms.